Hello everyone, welcome to our talk. The talk is basically about a field experiment which examined the intergroup theory as an intervention for reducing gender bias in software development context. We will keep it short and let's start in some background. So, you know, the problem of gender bias in software engineering is pretty well known among the researcher and the practitioners. We all know that. And there is a lot of evidence has been repeatedly reported in almost every place in software engineering. For example, in open source development, the pull requests initiated by the female developers are less likely to be accepted. So since we know that, we have limited way to reducing such biases. So how to fix it? So since bias is a psychological term, so we sought to some about social psychology theory. Among so many theories, we found the intergroup context theory by Gordon Allport, which proposed in 1954, it's a pretty good candidate. So the reason is, first, it works well in many social scenarios. Some social psychologist has reported it works well in thousands of social scenarios. And another way of it is pretty scalable. Why? There is always very high cost way to do the bias reduction. So for example, you let some people spending 10 days and have a mentor of him and try to tell him you have a bias and confront and let him to change their perception. It's okay, it works, but it takes so long. It's not scalable. It only could be applied to key personnel in your organization, for example, the CEO, right? And so we have two research questions. The first research question is intergroup context theory an effective intervention for reducing implicit gender bias in the software development context? So it's basically a general question. But there is a growing literature recognize that the intergroup theory has to be implemented in specific conditions, particularly specific contact conditions like the gender composition. So, for example, think about you have a 100 persons team, and if there is only one female, you perhaps don't get the good result as it has 50 male and 50 female, right? So first, let's look at the theoretical background of this work. First of all, we want to introduce something about gender bias. Gender bias could be explicit and implicit. To some degree, people now have a good way to deal with explicit gender bias, but not implicit ones. If you read our 2019 paper in ESEC, and you will find that people's decision making is not quite influenced by the explicit gender bias, but still being significantly influenced by the implicit bias. So implicit bias is very prevalent in many social scenarios. So what is implicit bias? Implicit bias is something you truthfully believe you don't have this kind of bias, but in your deep self you have it, and it's usually measured by implicit association test. So look at the right of this slides. So this is a screenshot of the test of gender career implicit association test. So in this kind of thing, you have the words referred with female for saying the her, and you need to associate with categories, and you perhaps think you don't have any bias, so you would always associate her with career and female, right? But sometimes your deep self will betray you, and you associate her with family and male, and it's wrong. So it will recording the time you're spending on each of these association decision scenario, and then compute the difference. The difference actually is an indicator of your implicit bias. If you want to try, you can go to the implicit project, attitude project hosting on Harvard, and try it, and you can see whether or not you have implicit bias and regarding gender issues. The second part of our theory background is intergroup context theory and optimal conditions. So basically, the central argument of the intergroup context theory is increasing interaction between different groups, for example, male and female, might help to reduce bias under some specific conditions. And Pettigrew has a lot of work on that. So we listed them in the key reference in the last slides. If you're interested, you can have a look at it. Allport suggests 4 optimal conditions. These conditions include the first one, equal status, second one, common goal, third one, cooperation, the last one, institution and social support. We don't want to go through every explanations, but let's have about their examples. So equal status. So software development team project leader and the team member are not in equal status, right? It's a counterexample. But in university, every student perhaps in a more equal status. The common goal is members of engineering senior project team have a common goal to finish their project on time so they can get a degree. This is the second. And the third, developers and requirement engineers cooperatively to develop high-quality software engineering system is an example of cooperation. And the last one, a manager of a global software engineering team encourages sub-teams in 2 locations to collaborate. This is kind of the institutional social support from the senior people or the social authorities, institutional authorities, actually. And we did an empirical study to test whether or not the intergroup context theory would help. And we have a student from Middlesex University who attended the introductory software engineering course during 2018 and 2019. We have 2 cohorts because one cohort does not have enough female students. You know that the computer science or software engineering are related subjects usually full of the male students rather than female students. We have 2 groups, control group and treatment group. In control group, basically, every team consists of the single gender members. So either team is consists of female or either team consists of all male. And we have treatment. Treatment allows the female and male to interact with each other, and they are mixed gender team. And there are 3 team configurations in the treatment. Basically, it's designed for the RQ2, and you can say there is a female majority and the equal gender and a male majority. However, we have to admit that the design has a limitation here. In the male majority, in the male majority team, which means female minority teams, and there is only 1 female in the team. Basically, 1 female team is not equal to the female minority team. So if you have 5 team members, you have 2 female, you can call it a female minority team. But indeed, we have 4-member team and only 1 female team. It's not necessarily constitute a minority team. This is a limitation of the study. And after that, let's say the study is how we implement output optimal condition. In the equal status, we assume that all students are similar to each other, and there is not much difference in their status within the university. And in the second condition, it has a common goal. You have to deliver the course project. And for the third one, a member of the team had to cooperate with each other to finish the task. Nobody can finish it by themselves. And in the last one, the instructor explicitly required team members to interact with each other. Then let's go to the second part of study design. So the experiment process contains three phases. The data collected twice. So we basically use the identical procedures into data collection. At the beginning, we're recruiting the result and obtaining their consent. In week 2, we assign participants into teams. Basically, it's randomly assignment. Through the week 3 and week 10, we let them interact with each other in the team. And at week 3, we're collecting the participants' explicit and implicit gender bias. And in week 10, we collect it again. By comparing the changes between the control and the treatment, we have an idea whether or not the intergroup context theory, which we implemented in the treatment condition, would be helpful. And we generate a set of the data, and for the explicit gender bias, we use a modern sexism scale. Basically, it's contained a statement like, it's easy to understand why women's groups are still concerned about social limitation of women's opportunities. And we have 3 IET implicit association tests, right? So the first one is gender career, the second one is SE general, and the last one is SE leadership, which we developed in another paper. So you can look at the left side of that. It has all these categories. In the gender career category, we have a career, home, male, female. And in the technical leadership, we have architect, or general software technical. And general software technical, we have SE technical and non-SE. So each associated with a set of the word. And as we noticed before, we care about the changes between the 2 data collection sessions. So, regarding the data analysis, we need to finish the task. First, remember that we have 2 cohorts because we don't have enough female participants at the beginning. So we need to test if they can be combined together. We did a column graph Seminoff test to say whether or not they could be viewed as data from the same distribution. Then, if so, we added them together. And in the second task, we answer the research question 1, so which is about the overall effectiveness of intergroup theory in reducing the gender bias. The test we did is hierarchical linear modeling, HLM. And why we didn't do an ordinary linear regression or something like ANOVA to compare the 2 conditions? The reason is our design is a nested design. So you say individual is basically embedded in teams. And in this kind of thing, the team characteristics, whether the team doing well in the project, is not independent. So they nested together with individual data. So we have to use hierarchical linear modeling rather than some kind of the ANOVA test or the ordinary least square regression. For RQ2, we want to check the effect of different team configurations. So the task is pretty similar to the last one. So we actually using the HLM to test it again, but with a different set of variables. So now we'll go to the results and finding. So basically, let's have a preview of that. Basically, the study confirms the effectiveness of the intervention based on intergroup context theory in gender bias reduction. It works. However, Its effectiveness is contingent on team's configuration. It basically means better results are achieved when the number of female participants in a team was greater or equal to the number of the male participants. If you bother to look at some details, first of all, we have the test of homogeneity. Basically, it tells us whether or not we could combining the two samples data, two cohorts data together. And it's showing that the two cohorts data is likely from the same distribution and pretty safe to combine them together. And then we run the two HLM. If you look at that at the beginning, you can see the overall effectiveness of the IGT of Intergroup per context theory. So and basically you can find that they did better than those in the control conditions, which without the any intergroup contact between the male and female. And in the second one, rather look at the blue box, unless the except one which there is no significant the model is not significant for the delta DSE column, but the rest of three all shows that if in the female majority team the bias reduction is doing better. So let's say what it means and what kind of the recommendation we could have. So the first one, software development organization may leverage intergroup context theory to reduce implicit gender bias. In general, it could be effective. And when assigning intergroup context, it could be better, or at least partially satisfy all possible conditions and allow an extended period for context. So it's not necessarily you could or you're able to implement all these for optimal condition, but at least some of them could perhaps be able to help according to some of the social psychologist literature. And using a max gender project team would be a good way to implement the intergroup context theory. However, the effect may not be good if female and minority team in a mixed gender team. At least you should avoid what we did. You should at least has 2 women in a 5-person team rather than 1 woman in a 4-person team, right? Don't make them to the only female in the team. And thinking about the current situation, there is a pandemic time, so face-to-face intergroup interaction are not possible. It may be worth trying to virtual simulated interaction. But so what? Does it work in the industrial environment? Maybe, but guarantee optimal condition could be very difficult. For example, in the industry and company, the environment is more competitive, and there is always different status in the organizational hierarchy, right? Manager and general team member are maybe different, as there is senior manager and there is CEO, CXOs, and assembling female majority team could be very hard because in the current situation of software development, I guess maybe 80% and 90% of the staff members are male. But anyway, it's often returned to the question that how much an organization wants to pay for reducing biases, right? So if they want to do that, they perhaps hire more female, and they perhaps creating a environment that promote this equal status thing. And the last one is, do we really need to rely on the real interaction or simulated interaction is good enough? I don't know. Simulated interaction might work, but would be likely to work for a moment only. It won't last. The effect won't last. So future research should be due to test whether or not it's a good way to do it. And as to a last question I have, shall we do it online or virtual world? And the key question in this one is how good virtual experience could translate to the real world perceptions. and we list the key reference. And thank you, everyone. Bye.